Okay, after we've created our schematic and we have our file, our mydetector.bdf saved, and we've added our 4 files, our QSF, our .vt, our .do, and our test framework, we're ready to move forward. So let's just take a look. Let's take a look at, we know that this is our .bdf. If we take a look at our QSF file, we're going to see that this is basically the rules that this Altera project uses to figure out what files to use and what assignments to use. Notice here that we have the names of our variables. A and B are our inputs going to switches, and so I have mappings here to the switches for switch 0 and switch 1. And then I also have our output F going to an LED. You won't ever have to make any changes to this. I just want you to be aware that you are downloading a .qsf file for every project, okay? So, because I'm not going to ask you to create one. When you start a new project, when you create a project, Quartus is going to create its own default QSF file, and you want to make sure that this one that you've downloaded is the correct one. If you happen to have 2, if you end up with errors, you can always go to the open and you can look for all of your files, go to all files, and then see if you happen to have 2 types of QSF files. Now notice I only have 1. Okay, it's always going to match to the name of your project. So you have to be really careful, but this is the one that you've downloaded. And so you should have that, and it should look like this. You should be able to open up and see that you have this. And then you have a couple test files. You have this Verilog test file, and notice the name mydetector test. Okay, that's the name that we're going to use for our test bench module. It has that name right here. Okay, and notice we have the name of mydetector test. We're going to use that name in a little bit. And then we also have this name here, and this name has to match the name of your .bdf exactly. And so also the variables have to match exactly, uppercase versus lowercase and so forth. So if you end up with problems, you should go and make sure, you can always look at your QSF file and make sure that the names that you used on your BDF match it exactly, lowercase and uppercase. Notice here I have A and B lowercase, and I have my F uppercase. And so that has to match this .vt file. And this basically is just going to run the test cases. I'm not testing every single project, every single circuit for every row of the truth table. Just like any product that you design, statistically, we should be able to choose certain ones to see how it works. And so that's what I've done for most of the labs, is I don't test everyone, I just check certain ones. So just be aware of that, okay? And we also have another .vt file. This basically is called by the first one to basically say, if you have errors, what are you going to do, and so forth. Or if it all runs right, what are you going to do? So that's those. You won't ever have to write any Verilog. You should never have to change those. And now notice that we have the .do file, again, the last file that you downloaded. This one sets up your waveform to look really nice. It puts all the inputs together and all the outputs together. It tells you how long to run it for, and so forth. So we have this .do file, and we're going to use that as well. So when we get ready to, first of all, we should make sure that we've run our compilation. Notice here also that mydetector.bdf must have this little symbol up at the top, right? And it must be first. It must indicate that this is my top level module. If you can always go through and you can set it as your top level module. Later on later projects, we're going to have multiple BDF files. Right now, this is really simple. We just have one. And so we want to always make sure that the one at the top is the one that we're trying to compile. We have that. Since I did that, you could always do a save all. So I'll go to save all. And then you could recompile. So, here it says that I've already compiled. I'm not going to run it again just for time. But if you don't have that, you should go until you compile it correctly. And so once it compiles correctly, if it doesn't, if it stops at 83%, what I want you to do is I want you to come up here to assignments and go to settings. I want you to go to the EDA tool settings so that you have this screen up. make certain that this run gate level simulation automatically after compilation is not checked. You do not want that checked, otherwise it will hang and keep trying to run the simulation, which you haven't even set up yet. So make sure that that is turned off. Also, make sure the format here for simulation is set to Verilog. We don't need that quite yet. Right now, all we really need, if you're hanging at 83%, you need to make certain that that is turned off. If you make changes, then you'll click apply and you'll say okay, right? So as long as everything's okay, we should be able to compile directly. Now when we want to set up our simulation, we're going to go actually back to the same settings. We're going to click on here, and then we're going to click on simulation. And so now we have a new screen. Some things that you're going to set. This should say Model Sim Altair. You shouldn't have to change this. This is where we've set the Verilog HDL. And we're going to check every picosecond. So I'm going to leave that at picosecond. We want to leave our output directory into the Model Sim. That works pretty well, right? So just leave it there. We don't need to write anyplace else. And actually, you can click on this Netlist Writer. A lot of students, for whatever reason, they need to change the generate netlist for functional simulation only. If you have this set to off, then you need to click it and you need to change it to on. It needs to be on. We only want to run functional simulations. We're only testing the truth table. We're not testing for timing. We're not checking the propagation delay of the transistors. And so for right now, all we want to do is run the functional simulation, and so leave that to on. And we'll say okay. All right, and now down here, you need to add a test bench for your compilation, okay? So I have one listed, but I want you to come here and click on test benches, and I want you to say new, okay? So when you say new, you're going to type in a name, and so you would do my detector test bench, right? And the name could be anything, but the top level module has to match the name of what we had our file, and our file was my detector test. And so really whatever you type up here will automatically be originally copied here. So you can leave it the same or both, or do it differently. So I have that the top level module is my detector test. You saw that. Okay, I'm going to not check the HDL. I don't care about that. Now the simulation period, I want to run all of the stimuli that I've provided, and so I'm going to make sure that that is clicked. I'm going to come down here to the test bench and simulation files, and I'm going to search for the .vt file called my detector test. So there it is, and I will open that. And so there I have my detector test. Once you add it, then it goes down here, and you'll say, okay, I'm going to say cancel because I already have one. And so I have my detector test, and it's in the file called mydetectortest.vt. It's exactly what yours should look like, and so you have that, and you can say OK, right? Now, you also want to set up the script, so you're going to use script to set up simulation, and you're going to search for the .do file. So once you find the .do file, you can click on that, and you should have it here. You'll say apply. Let me just check more native link settings, see if there's anything. Nope, we're not going to change anything there. We're going to leave it all the same, and we'll say apply, and we'll say OK. So once you've done that, you're really all ready to go ahead and run your simulation. So you'll come up here to Tools, and there's several ways you can get there. But we'll come to Tools, and we'll say Run Simulation Tool. And we want to run the gate level simulation, okay? So that's really where we're at. We're going to run the gate level simulation. So I'll click on that. It's a very big program. It takes a little while, so just be patient. And ultimately, you will see that it comes up. Let me reduce the size of this and bring it to the front. Actually, what I'll do is I'll increase the size of my Camtasia window. So hopefully I can do that. I'll try to do that. Maybe not. Maybe I can't do that. Okay, so then ultimately we have it coming up, and notice what you're looking for. You're looking for it to say all tests passed. That's what you want, and you want to have a full screen. Notice here that this is really minimized. Here I have all of my object names, and I will go ahead and actually delete that for now so that you can see the test benches, right? And so here I have my test bench. I have it set so that my inputs are A and B, and I'm testing each of the cases. Here I have where they're both 0. Here I have A is 0 and B is 1. A is 1 and B is 0, and they're both 1. Okay, and then I'm looking at the output. What is the output of F? And here I have the output of F. I can look at the test names by zooming in. I'm going to move this down. Oh, no, actually, I'll leave that there. And so I can zoom in. I will zoom in by clicking here. Notice I get a yellow line, right? And I can zoom in by coming here and saying zoom in, right? And so that would allow me to keep zooming in. And I could click that 100 times. There's a lot of different ways that you can get there. You can go to view and zoom in that way as well. And so, yeah, view and whoops, view doesn't take me to it. But anyway, play around with it and you can find out. You know, the easiest thing is to just keep clicking that zoom in, right? And so I'm sure you guys will all come and tell me exactly how to do it. Notice here I have that no motion dark is when they're both 0, no motion light. Motion dark is where it should turn 1, and then motion light, the output should be 0, which I have right here. And so we see that, and we have the names of all of the tests, checking each one. But ultimately what you want to check is you want to have it say all tests pass, which it does here. Then you would take a screenshot of your full screen, and then you would post that into your document file to say that the simulation ran correctly. Okay, and that's your simulation. Okay.